Hi Year 4, welcome to our maths for today. We are going to be rewinding again using learning by questions as a bit of an end of topic kind of rewind, because it's important to keep rewinding even to the things that we think we've moved on from. And today we're going to be rewinding our knowledge of shape, because I know it's something we found very tricky. I found it tricky to teach, and I know that you guys might have found it a bit tricky at home as well, because it's not something that we focus on a lot in school when we're doing place value and things. It's a completely different kind of topic. So we're going to rewind a lot about shape. So today we're looking at triangles in particular. And let me show you the what, how, and why, so you know the specifics. So we are going to retrieve our knowledge of shape by retrieving that old learning so that we can solve a number of problems involving classifying triangles. And like I've said, this is something that I find really tricky. Okay, so you're definitely already doing better than me. I find triangles so tricky, I can't remember which one is which, and I do genuinely forget them. And so it is very tricky. So I find it tricky, I found it hard to teach. So I'm sure that you guys already have much more of an understanding of triangles than me. Maybe you should be teaching me. What are the names of the three different types of triangle? I'd like you to just make a note of them. You should write 3 words down for question 1. So if we're thinking about triangles, we are thinking about the word tri. Tri means 3, like on a tricycle. So triangle means that there are going to be 3 sides and also 3 points, 3 corners, 3 angles, what you want to call them. So if we are drawing an arrow that looks a bit like this has got more than 3 sides. 1, 2, 3, 4. So it's not a triangle. Equilateral is a type of triangle. Tick, well done. Isosceles is a type of triangle. Well done. Tick. And a diamond, again, is a, that looks awful, sorry guys. A diamond is a quadrilateral, so it has 4 sides, not 3. So you should have equilateral, isosceles, and then scalene as your triangles. Now, an equilateral triangle has, now if I'm looking at this, 3 different sides, 3 equal sides, or 2 equal sides. I'm thinking about the word that I can see there, equilateral. What do I know about the word equilateral? Have a think. So the answer is that it's got 3 equal side lengths, okay? All 3 sides of that triangle are the same because it's equilateral, okay? This triangle has 2 equal sides and 1 different side. So that makes it what kind of triangle? I want you to pause and have a think. And so hopefully you filled in and recognise that this is not an equilateral because it's not all equal. It is an isosceles triangle, okay? And the reason I know it's an isosceles triangle, this is my thinking, I know this is an isosceles triangle because a scalene triangle has nothing the same, but this has 2 the same. Okay, and I know I mentioned this when I was teaching in school. This is how I remember a scalene triangle, because if I remember equilateral is equal, and if I remember scalene, then whatever's left is the isosceles. So the way that I remember a scalene is, I think about snakes with all of their scales, and I think about the fact that they have no legs, which is very random, but it helps me. So maybe there's something in those words that you can use to help you. So I think about scaly snakes, and I think they have no legs because they slide on the floor. Like I say, it makes absolutely 0 sense to be thinking about triangles and snakes at the same time, but it helps me. So this triangle has 2 equal side lengths, so it is an isosceles. Now, Miss Nook has just said, scalene triangle, a snake with no legs, has 3 different side lengths, 3 equal side lengths, or 2 equal side lengths. Pause and have a think for me. So a scalene triangle has 3 different side lengths. So that's the first option there. Got none the same, so therefore all three are different. Okay, so having a look at this one. Which two triangles have right angles? Now, let me just rewind my understanding, rewind my knowledge. When I think about angles, I know that acute angles are the little tiny angles, and obtuse angles are the very big ones. And a right angle is, if I remember correctly, what we imagine as a perfect corner. So this is a right angle. If I'm looking at squared paper, then in this instance, because they're all straight on, I can see which shapes have got a perfect corner or a perfect right angle. I can see that this one here on D is trying to trick me, but I know at home you guys haven't been fooled. Because shape D does not have a right angle because that is a little bit bigger than the perfect corner there, and so it is obtuse. So I'd like you to write down the two that have got a right angle. So shape A has got a right angle. And if I just draw the little shape that we have when we've got a right angle. It's probably a bit small, okay, looks all right. So A has a right angle, and so does C in that top corner there. So A and C have a right angle. Now, before we move on, you might notice, Miss Nogue, I've never seen lines drawn across a triangle like that. Okay, all that means is that they are equal. These two lines are the same. These two lines are equal. So that means that this angle here, if it's got two sides that are the same, is an isosceles. This one's got all the three the same, so it's an equilateral. This one has got no sides, no lines showing that the sides are the same. So it's a scalene. And then D, again, it's got none of those lines. So it's telling me that there's nothing the same. So it is also a scalene. Now, the difference between C and D is that C is a right-angled scalene and D is a scalene. And all we did is said right-angled scalene because it's got a right angle. Okay, so I'm not going to explain that too much. It's quite self-explanatory. C and D are both scalene. C is a right-angled scalene. D is just a scalene. Scalene, 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 scalene. I obviously like that word. Oh, something's just fallen off the wall. So, that might help us for this side. Which two properties describe a right-angled isosceles triangle? So looking at that, I can use my knowledge. I already know what right angled means. I already know what isosceles means. So I think I can find those two features or two properties out of that list. You go first. Okay, so this triangle is a right angled isosceles triangle. So therefore it has got a right angle, first of all. And if I were to add my little doodle, I'd be adding it down here, look. So it has got a right angle. And then it has three equal side lengths. No, equal is equilateral, so that's a no. It has two equal side lengths, or it has three different ones. I can't remember which one means that we have got zero the same. Three the same is equilateral. Zero the same is my snake with no legs, which is scalene. That's not equilateral and it's not scalene, so it's not three, it's not zero, it's got two equal side lengths. Okay, and with this, it's just practicing those three names and those three features until they're stuck in our memories. There's not too much we can do except keep going over it. So, oh, Miss Note, we've finished. I didn't realise I'd not got any more questions for you. So you are going to have a go at those questions that are going to be set on learning by questions. And you are then going to the answer, you don't even need to send the answers in because they'll already be sent in. So for your maths this week, it's quite nice for you because you just have to do it online and we can see that you've gone on to do it. Okay. Fab. Have a lovely rest of your day. And not that I'm counting, but after this, there are only 2 more school days until we get to see all of you again. So I will see you very soon. And this time I mean it. So see you later, guys. Have a wonderful rest of your day.